Hi class. In this lecture, I want to do just a real brief introduction to both section 3.3 and 3.4. So what I'm going to do is kind of lay out the major ideas or themes in it. And then from there, what you'll do is you'll supplement this lecture with the textbook reading, which does a fantastic job going into a little bit more detail than I do here. Okay, so section 3.3 is called the missing member. And there was this mathematician named Greg Cantor who kind of asked this question. Are some infinites larger than others? So what I've talked about in the previous lectures is that, there's a one-to-one correspondence, say, between the set of integers and the sets of natural numbers. But like literally just intuitively, it's like, well, even though both sets are infinite, there's seems to be, quote unquote, more integers than natural numbers. So the question of the day here, the question of this lecture, is there an infinite set, quote unquote, bigger than the natural numbers? Okay, so bigger than the natural numbers. So there's this theorem by Cantor, and what he said is there are more real numbers than natural numbers. So remember, natural numbers are like 1, 2, 3, 4, 5, so on and so on. And the natural numbers are numbers like 1, 1.1, 1.2, -5, -7. So just intuitively thinking about it, it would seem that there are more real numbers than natural numbers. Okay, so that moves us into section 3.4, where we talk about something called the power set. And again, here's the question: is there an infinite set, quote unquote, bigger than the real numbers now? So we were talking about there being more real numbers, quote unquote, more or bigger numbers than the natural numbers, but now is there something more bigger, quote unquote, than the real numbers? So let's just do a quick review here of sets. So a set is a collection of objects, we know that. And the empty set is the set that contains nothing. Okay, there's nothing in that set. And the thing about the empty set is it's what's called a subset of every other set. And a subset is a set within a set. So there's this rule. So the number of subsets for any specific set. So a set containing n elements has 2 to the n subsets. So for example, if a set has 3 elements, it would be 2, the number of subsets would be 2 to the third. So 2 to the third mean that set would have 8 subsets. So there's this thing called the power set. And the power set is the set that contains all subsets of a set. So for example, if you have the set of the elements 1, 2, the power set, which we denote as an italicized P of that specific set, is all the subsets of this. So, it's the empty set, the set of 1, the set of 2, the set of itself, 1, 2. So for example, remember, if there's 2 elements, that means there's 2 to the n, or 2 squared, 4 subsets. And you can see this is the same thing with the 3. If you have the letters A, B, C, there's 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 subsets. So you can see the same thing here. If you have 4 elements, this is the sets of a deck of cards. That would be 2 to the 4th. Okay, 2 to the 4th would be 2, 4, 8. There should be 16 subsets. Okay, so now think about this. We have this set. Okay, and then you have this thing called the power set, which is the set of all subsets. So think about this. If you let S be a set, either infinite or infinite, then the cardinality of the power set is always strictly greater than the cardinality of S. It's always greater than. Okay, even if it's an element of one set or one set of 1 elements, then 2 to the first power, the power set has two elements in it, so it's already larger. So when we talked about what's bigger than the real numbers, okay, all right, this is what's called the Continuum Hypothesis. And it says there is no cardinality between the cardinality of the set of natural numbers and the cardinality of the set of real numbers. And this is sometimes referred to as the continuum. And to go back with our first question here, is there a set bigger than the set of real numbers? Well, absolutely. And if you quote unquote think about it this way, it'd be the power set for the set of real numbers. All right, I know this was just a quick, brief introduction, but if you go back into your text and read everything that read over what I've talked about, everything will make a little bit more sense.